Hey guys, in this tutorial you learn NumPy from 0 to hero. So let's start. What is NumPy? NumPy is a Python library used for working with arrays. It also has functions for working in domain of linear algebra, Fourier transform, and matrices. NumPy was created in 2005 by Travis Oliphant. It is an open source project and you can use it freely. NumPy stands for Numerical Python. Why use NumPy? In Python, we have lists that have served the purpose of arrays, but they are slow to process. NumPy aims to provide an array object that is up to 50 times faster than traditional Python lists. The array object in NumPy is called ND-array. It provides a lot of supporting functions that make working with ND-array very easy. Arrays are very frequently used in data science, where speed and resources are very important. Why is NumPy faster than lists? NumPy arrays are sorted at one continuous place in memory, unlike lists. So processes can access and manipulate them very efficiently. This behavior is called locality of reference in computer science. This is the main reason why NumPy is faster than lists. Also, it is optimized to work with latest CPU architectures. Which language is NumPy written in? NumPy is a Python library and is written partially in Python, but most of the parts that require fast computation are written in C or C++. Hey guys, in this part we install the NumPy. If you have Python and pip already installed on a system, then installation of NumPy is very easy. I install NumPy with this command and import NumPy. If this command fails, then use a Python distribution that already has NumPy installed, like Anaconda, Spider, and etc. So import NumPy. Again, show the command. This command. Import NumPy. Import NumPy, and now NumPy is imported and ready to use. So for example, array, create a variable, and NumPy dot array, and 1, 2, 3, and 4, and 5, and print array. Save and run the file, and we have this array. And NumPy as NP. NumPy is usually imported under the NP alias. So NumPy as NP, and create an. So now the NumPy package can be referred to as NP instead of NumPy. So in here use np.array. Save and reload, save and run, and we have this array. And checking NumPy version. The version string is stored under np.version attribute. Save and run, and I have this version of NumPy. Hey guys, in this part we talk about creating arrays in NumPy. Create a NumPy and the array object. NumPy is used to work with arrays. The array object in NumPy is ND-array. We can create a NumPy ND-array object by using the array function. So import NumPy as NP, and array is np.array, and 1, 2, 3, 4, 5, and 6, and print array, and print type of array. Save and run. We have the array and type of array numpy.nd array. To create an nd array, we can pass a list, tuple, or any array-like object into the array method, and it will be converted into an nd array. So for example, I change the list to the set and run again, and we have the same result. And dimensions in arrays. A dimension in arrays is one level of array depth. 0D arrays. 0D arrays or scalars are the elements in an array. Each value is an array is a 0D array. So for example, comment this, and array will equal to np.array, for example 40 is an 0D array. Run, and we have this. And 1D arrays. An array that has 0D arrays as its element is called unidimensional or 1D array. These are the most common and basic arrays. So 1, 2, and 3, and 4 is an 1D array. Save and run, and we have this. And 2D arrays. An array that has 1D arrays as its elements is called a 2D array. These are often used to represent matrix or second order tensors. So NumPy has a whole submodule dedicated towards matrix operations called numpy.mat. So 2D arrays is, for example, this, and 5, 6, and 7. Save and run, and we have an error. What the error? Why? Yeah, and 8. Save and run, and we have the 2D array. And 3D arrays. An array that has 2D arrays or matrices as its elements is called 3D array. These are often used to represent a 3D ordered tensor. So comment this, copy and paste, and so copy this, cut this, and paste here, and paste again, and change the values. For example, 9, 10, 11, and 12, and 30, 14, 15, and 16. Save and run. And we have a 3D array. And check number of dimensions. NumPy arrays provides the ndim attribute that returns an integer that tells us how many dimensions the array have. So I uncomment this array, create another np.array 1, 2, and 3, and another array np.array 30 and 1 2 3 and 4, save and print array y dot ending, copy paste and paste, and 2 3 and 4, save and run. 0, this is 0 1 2 and 3 dimensions. Higher dimensional arrays. An array can have any number of dimensions. When the array is created, you can define the number of dimensions by using the endmean argument. So in here I set the endmean to 5 and comment, and in here print array2 and print number of dimensions is array 2 dot ending, save and run. And we have this array and number of dimensions is 5. Hey guys, in this part we talk about array indexing in NumPy. Access array elements. Array indexing is the same as accessing an array element. You can access an array element by referring to its index number. The indexes in NumPy arrays start with 0, meaning that the first element has index 0 and the second has index 1 and etc. So array is empty dot array and 1 2 3 and 4 and print array and index 0, and we should have 1. Run and we have 1. And you can get the second element from the following array, this, and we should have 2 and 2. And we can have array index 1 plus array index 3, and we should have 2 plus 4. Run and we have 6. And access 2 dimensions arrays. To access elements from 2D arrays, we can use comma separated integers representing the dimensions and the index of the element. Think of 2D arrays like a table with rows and columns, where the row represents the dimensions and the index represents the column. So I change this array to 2D array, this, and add 5 in here, and 6 7 8 9 and 10, and we have a 2D array. So in here print second element on first row is array and 0 and 1. This first row and second element is 2. So write first element and second column. Run and we have 2. And for example, fifth element on second row, second row and 1, 2, 3, 4 and fifth element. So right, second row and fifth element, right, and run. We should have 10. And access 3D arrays. To access elements from 3D arrays, we can use comma separated integers representing the dimensions and the index of the element. So I cut this and paste here. So I copy the array and paste, and so this and this, and beautiful the code. So we have this 3D array, and so access the third element of the second array of the first array. So comment this and another print and array. So on the first array, this is second array, this, and third element, this. So right, first array is 0, and second array in first array, this is 1, and third element, so 2. Save and run, and we have 6. And negative indexing. Use negative indexing to access an array from the end. So I copy and comment this, paste, remove and remove. So remove and 1, 2, 3 and 4 and 5 and 6, 7, 8, 9 and 10. Save and print last element from second dim and array, and so last element from second dim. Second dim is 1 and last element is -1. Save and run, and we have 10. Hey guys, in this part we talk about array slicing in NumPy. Slicing in Python means taking elements from one given index to another given index. We pass a slice instead of index like this. Start and end. And we can also define the step like this. And define a step. And if we don't pass a start, it's considered 0. If we don't pass end, it's considered length of array in that dimension. If we don't pass a step, it's considered 1. So I import the NumPy as np, and array is np.array, and 1, 2, 3, 4, 5, 6 and 7, and print array index 1 to index 5, index 1 to index 2, 3, 4, and 5. Save and run, and we have this index 1 to index 5, and we don't have index 5. And for example, a slice element from 4 to the end. Save and run. 1, 2, 3, and 4. Sorry, 0, 1, 2, 3, and 4 to end. Run, and we have this 5, 6, and 7. And or from 0 to 4. Save and run, and we have this. And negative slicing. Use the minus operator to refer to an index from the end. So for example, print array and -3 and -1. -3 is, so run, and we have this -3 is 1, 2, and 3, this to -1, this, and we don't have -1. And a step. Use the step value to determine the step of the slicing. So for example, print array and from 1 to 5, and step is 2. Save and run, and we have this 1 to 5, this, and step is 2. And return every other element from the entire array. So copy and paste and remove this and this, and so run, and we have this from index 0 and to the end, and step is 2. And slicing to the arrays. So I copy and paste an array 2, um, 1, 2, 3, and 4, and 5. Another array 6, 7, 8, and 9, and 10. And print array and index 1, and from 1 to 4. Save and run, and array 2, sorry, run, and we have this index 1 from 1 to 2, 3, and 4. From 1 to 4, this. And or we can get from both elements, return index 2. Print array 2, and from both elements, index 2, index 2, 3, and 8. Save and run, and we have this. Or get from both elements slice index 1 to index 4, and this will return a 2D array. Print comment and comment, print array 2, and from both elements, and index 1 to index 4. So both elements and index 1 to index 4, and index 1 to index 4. Save and run, and we have this 2D array. Hey guys, in this part we talk about copy and view in NumPy. The difference between copy and view. The main difference between a copy and a view of an array is that the copy is a new array and the view is just a view of the original array. The copy owns the data and any changes made to the copy will not affect the original array, and any changes made to the original array will not affect the copy. The view doesn't own the data, and any changes made to the view will affect the original array, and any changes made to the original array will affect the view. So copy, import NumPy as np and make a copy, change the original array and display both arrays. Array, so array is np.array and 1 2 3 4 and 5, and x is array dot copy and array index 0 is 42 and print both arrays. Save and run. And this is array, and this is x, and the copy shouldn't be affected by the changes made to the original array. And view, make a view, change the original array and display both arrays. So I comment this, copy and paste, and array dot view, save and run, and this is array and this is x, and the view should be affected by the changes made to the original array. And check if array owns its data. Copies owns the data and view doesn't own the data. But how can we check this? Every NumPy array has the attribute base that returns none if the array owns the data. Otherwise, the base attribute refers to the original object. So y is array dot copy and print y dot base and x dot base. Save and run. And the y has own data and we have none, and x is view and we have refer to the original object. Hey guys, in this part we talk about data types in NumPy. By default, Python has these data types: strings, integer, float, boolean, and complex. Data types in NumPy. NumPy has some extra data types and refer to data types with one character, like I for integers, U for unsigned integers, and etc. So I is integer, and B is boolean, boolean, and U is unsigned integer, and F is float, C is complex float, and M is time delta, N is date time, and O is object, S is a string, U is Unicode, a string, and Y and checking the data type of an array. The NumPy array NumPy array object has a property called dtype that returns the data type of the array. So import NumPy as np and array is np.array and 1 2 3 and 4 and print array.dtype. Save and run. Sorry. Run, and we have int 32, and or create another array a and b and c. Sorry, a and b and c, and array2 dot data type. Run, and we have this, and creating arrays with a defined data type. We use the array function to create arrays. This function can take an optional argument dtype that allows us to define the expected data type of the array elements. So in here I set the dtype to the s string and print array. Save and run, and we have this. And for I, u, f and s and u, we can define size as well. For example, dtype is I4. This is size. Save and run, and we have this. And if I change the size to 5 and save, we have the error. And what if a value cannot be converted? If a type is given in which elements can't be casted, then NumPy will raise a value error. So for example, in here, or I create another array 3 and a 1 and 3, and data type is I. Save, and the a can convert to the integer. Run, and we have an error in a. And converting data type on existing arrays. The best way to change the data type of an existing array is to make a copy of the array with the asType method. The asType function creates a copy of the array and allows you to specify the data type as a parameter. The data type can be specified using a string like f for float, I for integer, and etc. Or you can use the data type directly like float for float and int for integer. So for example, I create a new array and array dot, so I change the array to 1.1, 2.1, 3.5 and 5.7, and new array is array dot asType and I. Save and print new array and new array dot dtype, and comment these prints. Run, and so in here comment this. Run, and we have int 32 and these values without floats. Or you can define new array like this. save and run, and we have the same result. And change the data type from integer to boolean. For example, array 3 is np.array and 1 0 and 3, and new array is array as type bool, and run. And so array 3, yeah, and we have true, false, 0 is false, and true, and data type is boolean. Hey guys, in this part we talk about array shape in NumPy. The shape of an array is the number of elements in each dimension. NumPy arrays have an attribute called shape that returns a tuple with each index having the number of corresponding elements. So import NumPy as np and array np dot array, and we have a 2-dimension array, so 1 2 3 4 and 5 6 7 and 8, and print array dot shape, save and run, and we have 2 and 4. This means that the array has 2 dimensions, where the first dimension has 2 elements, 1 and 2, where the first dimension has 2 elements and the second has 4. So I create another array. Array 2 is np.array and 1 4, and endmin is 5, and print array 2 and array 2 dot shape, save and run, and we have this. What does the shape tuple represent? Integers at every index tells about the number of elements the corresponding dimension has. In this example, at index 4 we have value 4, so we can say that the fifth dimension has 4 elements. Hey guys, in this part we talk about array reshaping in NumPy. Reshaping means changing the shape of an array. The shape of an array is the number of elements in each dimension. By reshaping, we can add or remove dimensions or change number of elements in each dimension. So reshape from 1D to 2D. Convert. So import NumPy as np, and I create a array. So np.array and 10 11 and 12, and so new array is array dot reshape 4 and 3, and print new array. So the outermost dimension will have 4 arrays, and each with 3 elements. Run, save and run, and we have this 1 2 3 and 4, and in each array we have 3 elements. And reshape from 1D to 3D. Comment and copy and paste, and 2 and 3 and 2. So the outermost dimension will have 2 arrays that contains 3 arrays, each with 2 elements. Save and run, and we have 2 arrays, and in each array we have 3 arrays and 3 arrays, and in each array we have 2 elements. And can we reshape into any shape? Yes, as long as the elements required for reshaping are equal in both shapes. We can reshape an 8 elements 1D array into 4 elements in 2 rows 2D array, but we cannot reshape it into a 3 elements 3 rows 2D, as that would require 3 by 3 equal to 9 elements. So for example, new array is array that reshape and 3 and 3, and this will raise an error, and we have an error: cannot reshape array of size 12 into shape 3 by 3, and returns copy or view. So check if the returned array is a copy or a view. Print array dot reshape and 2 and 4, and remove these elements, and dot base. Save and run, and this return view. An unknown dimension. You are allowed to have one unknown dimension, meaning that you don't have to specify an exact number for one of the dimensions in the reshape method. Pass -1 as the value, and NumPy will calculate this number for you. So convert 1D array with 8 elements to 3D array with 2 by 2 elements. In here, new array is array dot reshape and 2 and 2 and -1, and print new array. Save and run, and we have 2 arrays, and in each array we have 2 arrays, and in each array we have 2 elements. And flattening the arrays. Flattening arrays means converting a multi-dimensional array into a 1D array. So we can use reshape and -1 to do this. So new array and pass new -1, sorry, and run, and we have this. So for example, I cut this and paste and paste, remove and remove, save and run, and we have this result. Hey guys, in this part we talk about iterating arrays in NumPy. Iterating arrays. Iterating means going through elements one by one. As we deal with multi-dimensional arrays in NumPy, we can do this using basic for loop of Python. If we iterate on a 1D array, it will go through each element one by one. So cls and import NumPy as np, and array is np.array 1, 2, and 3, and for x in array and print x. Save and run, and we have 1, 2, and 3. And iterating 2D arrays. In a 2D array, it will go through all the rows. So array 2 is np.array cut and paste and 4 and 5 and 6, and save and run, and array 2 run again, and we have 2 rows. And to return the actual values, the scalars, we have to iterate the arrays in each dimensions. So iterate on each scalar element of the 2D array. In here, for y in x, and in print y. Save and run, and we have the values. And iterating 3D arrays. In a 3D array, it will go through all the 2D arrays. So cut this and paste and paste in here 7, 8, and 9, and 10, 11, and 12. Save and in here, so print x and run, and we have this. And to return the actual values, the scalars, we have to iterate the arrays in each dimension. So for y in x and for z in y, and print z. Save and run, and we have the values. And iterating arrays using and the iter. The function in the iter is a helping function that can be used from very basic to very advanced iterations. It solves some basic issues which we face in iteration. Let's go through it with examples. So iterating on each scalar element. In basic for loops, iterating through each scalar of an array, we need to use and for loops, which can be difficult to write for arrays with very high dimensionally. So comment this, and so for x, sorry, I create another array, yes, another array, np.array, and 1 and 2, 3 and 4, and 5, 6, 7, and 8. So print the array 3, and so what's wrong? So enter enter and enter what's in here and save and run. And so what's wrong? Run, and we have this array. So cls and for x in np.nditer and set array and print x array3 run, and we have the values. An iterating array with different data types. We can use underline d types argument and pass it the expected data type to change the data type of elements while iterating. NumPy doesn't change the data type of the elements in place, and so it needs some other space to perform this action. That extra space is called buffer, and in order to enable it in nditer we pass flags and equal to buffered. So code for x in mp.nditer and array3 and flags is buffered and op underline data types is s and print x run, and we have this as a string. And iterating with different step size, we can use filtering and followed by iteration. So iterate through every scalar element of the 2D array and skipping one element. So this is a 3D array. So in here comment this, and after I create array4 is mp.array and 1 2 3 and 4 and 5 6 to 8 and for x in np.nditer and array and set step and print x, save and run. And what's wrong? So comment this and run again. So failed elements must be 2 or 3 tuples. You have an error in here. Save and run. What's wrong? Too many indices for array in. So what's wrong? In here array4 run, and we have 1 3 5 and 7, and step is 2 1 3 5 and 7. And enumerated iteration using nd enumerate Enumeration means mentioning sequence number of some things one by one. Sometimes we require corresponding index of the elements while iterating. The ND-enumerate method can be used for those on C cases. So enumerate on following 1D arrays elements. In here we have an 1D array, and so comment, and so 4 and idx and x in and x in nd dot enumerate mp nd enumerate and send array and print x and or idx and x. Save and run, and we have this 0, 1 and 2 and 1, 2 and 3 index and index, and enumerate on following 2D arrays elements. So we have a 2D array 4, and so send array 4 and run, and we have this index 0 and 0, 1, 0 and 1, 2, and etc. Hey guys, in this part we talk about joining array in NumPy. Joining means putting contents of 2 or more arrays in a single array. In SQL we join tables based on a key, whereas in NumPy we join arrays by axes. We pass a sequence of arrays that we want to join to the concatenate function, along with the axis. If axis is not explicitly passed, it's taken as 0. So import NumPy as np, and array1 is np.array, and 1, 2 and 3, and array2 is np.array, and 4, 5 and 6, and array is np.concatenate array 1 and array 2, and print array. Save and run, and we have this result in a single array. Or join two 2D arrays along rows. Axis is 1. So array 3, copy and paste array 3 is 1 and 2 and 3 and 4, and in here four and 5, 5 and 6, and 7 and 8, and array is np.concatenate array 1 and array 2, no, array 3 and array 4, and axis is 1. Print array 4. Run, and we have this in a single array, and axis is 1. And joining arrays using stack functions. Stacking is same as concatenation. The only difference is that stacking is done along a new axis. We can concatenate two 1D arrays along the second axis, which would result in putting them on over the other. We pass a sequence of arrays that we want to join to the stack method along with the axis. If axis is not explicitly passed, it is taken as 0. So array 1 and array 2, and array is np dot stack array 1 array 2, axis is 1, and run, and we have this result 1 4 2 5 and 3 and 6. So if axis is 0, we have this result. And stacking along rows. NumPy provides a helper function hstack to stack along rows. So copy and paste and hstack and remove the axis, and yeah, run, and we have this in a single array. And stacking along columns. NumPy provides a helper function vstack to stack along columns. So vstack and run, and we have this and stacking along height or depth. NumPy provides a helper function dstack to stack along height, which is the same as depth. So copy and paste and dstack and save and run, and we should have 1 4 2 5 and 3 and 6. Run, and 1 4 2 5 and 3 and 6. Hey guys, in this part we talk about splitting array in NumPy. Splitting is reverse operation of joining. Joining merges multiple arrays into one, and splitting breaks one array into multiple. We use array underline split for splitting arrays. We pass it the array we want to split and the number of splits. So import np and arrays np dot array 1 2 3 4 5 and 6, and new array is np dot split array and 3, and print new array. Save and run, and we have 1 2 3 and 4 and 5 and 6, and we have 3 elements. And if the array has less elements than required, it will adjust from the end accordingly. So for example, new array and 4, run, 1 2 3 and 4 5 and 6, and in one array we have 4 elements. And note, we also have the method split available, but it will not adjust the elements when elements are less in source array for splitting, like this example. Array split work properly, but split would fail. And split into arrays. The return value of the array split method is an array containing each of the splits as an array. If you split an array into 3 arrays, you can access them from the result just like any array element. So for example, changing to 3 and 1 0 1 and 2. Save and run, and 1 2 3 4 and 5 and 6, and splitting to the arrays. Use the same syntax when splitting 2D arrays. Use the array split method, passing the array you want to split and the number of splits you want to do. So change the or copy and paste. Array is in here 1 and 2. Copy, paste and paste. 1 and 2, 3, 4, 5, 6, 7 and 8, 9 and 10, and 11 and 12. Save and so new array, np array split array and 3, and print new array. Save and run, and we have this. In an array we have an array and an array and an array, and 1, 2, 3 and 4, 5, 6 and 7 and 8, and 9 and 10 and 11 and 12. And so let's look at another example. This time each element in the 2D arrays contains 3 elements. So I change the array 3 is copy and paste and remove 1, 2 and 3, 4, 5 and 6, 7, 8 and 9, and 10, 11 and 12, 30, 40 and 50, and 60, 17 and 18. Sorry. And see the result, array 3. Yeah, run, and we have this. In one array we have 1, 2, 3 arrays, and in each array we have one array, and in an array we have 2 arrays. And in addition, you can specify which axis you want to do the split around. So the next example, also returns 3 2D arrays, but they are split along the row. Axis is 1. So set the axis 1, run, and we have this result. So and we have in array we have 1, 2 and 3 arrays, and in each array we have one array and 1, 4, 7, 10, 30 and 16. 1, 4, 7, 10, 30 and 13 and 16, and like this. And an alternate solution is using h-split opposite of h-stack. So use h-split, copy and paste. New array is np.hsplit, and remove the axis, run, and we have the same result. Hey guys, in this part we talk about searching arrays in NumPy. You can search an array for a certain value and return the indexes that get a match. To search an array, use the where method. So import and array is np.array. Sorry, 1 2 3 and 4 and 5 and 4 and 4, and x is np.where array is 4, and print x. Save and run, and we have this, and this means that the value 4 is present at index 3, 5 and 6, and find the indexes where the values are even. So I copy and paste. Array 2 is 1 2 3 4 5 6 7 and 8, and x is np.where array present 2 is 0. Save and run, and we have this. In index 1 3 5 and 6 we have even numbers. Index 1, index 3, index 5 and index 6. Why? 0 1 2 3 4 5 and 6. The 6 is wrong. Why? Run again. 1 3 and 5 and 6. Why? So yeah. Alright, 2. I'm sorry. 1 3 5 and 7, and find the indexes where the values are odd. So in here is 1, and run, and 0 2 4 and 6 are odd in here. And search sorted. There is a method called search sorted which performs a binary search in the array and returns the index where the specified value would be interested to maintain the search order. So the search sorted method is assumed to be used on sort arrays. So array 3 is np.array, and 1 2 3 4 and 6 7 8 and 9, and x is np.search sorted array, and the value is 7, and run, and so what's wrong? X is an array 3, run, and we have 1 0 and 1, and the method starts the search from the left and returns the first index where the number 7 is no longer larger than the next value. So search from the right side. By default the leftmost index is returned, but we can give side is right to return the rightmost index instead. So in here side is right. Save and run, and we have 2 0 1 and 2. Hey guys, in this part we talk about sorting arrays in NumPy. Sorting means putting elements in an ordered sequence. Ordered sequence is any sequence that has an order corresponding to elements like numerical, alphabetical, ascending or descending. The NumPy in the array object has a function called sort that will sort a specified array. So import NumPy as np and array is np.array and 3 to 0 and 1 and print array dot sort np dot sort and send array run and 0 1 2 and 3, and this method returns a copy of the array, leaving the original array unchanged. You can also sort arrays of strings or any other data type. For example, fruits equal to np.array and banana, cherry and apple, and print np.sort fruits, save and run, and apple is first, banana and cherry. Or for example, array 2 is np.array and sort a boolean array. For example, true, false, true and false, and print np.sort array 2 and false, false, true and true, and sorting a 2D array. If you use a sort method on a 2D array, both arrays will be sorted. So for example, array 3 is a 2D array, 3, 2 and 4, and next 5, 0 and 1, and array 3, save and run, and 2, 3 and 4, and 0, 1 and 5. Hey guys, in this part we talk about filter array in NumPy. Getting some elements out of an existing array and creating a new array out of them is called filtering. In NumPy, you filter an array using a boolean index list. A boolean index list is a list of booleans corresponding to indexes in the array. If the value at an index is true, that element is contained in the filtered array. If the value at that index is false, that element is excluded from the filtered array. So import NumPy as np and array is np.array 41, 42, 43 and 44, and x is true, false, true, false, and new array is array and x as a boolean list, and we have array, and print new array, save and run, and we have 41 and 43. Why? Because the new array contains only the values where the filter array had the value true. In this case, index 0 and index 0 and index 2 are true. So creating the filter array. In this example, we hard-coded the true and false values, but the common use is to create a filter array based on conditions. So for example, create a filter array that will return only values higher than 42. So remove this, and filter array is a empty array, and remove this and remove this. For go through each element in array. So for element in array, and if the element is higher than 42, set the value to true, otherwise false. So if element higher than 42, filter array dot append true, else filter array dot append false, and new array is array and filter array as boolean list, and print filter array print new array. Run, and we have false and false because 41 and 42 are less than 42 and are less or equal to 42, and 43 and 44 are higher than 42. So false and false and true, and we have 43 and 44. Or create a filter array that will return only even elements from the original array. So comment this, and so comment get elements are higher than 42, and get even elements. So copy this, paste here, and uncomment, and if element is even, filter array dot append true, and else filter array dot append false. Save and run, and we have 42 and 44 false, true, false, and true. And creating filter directly from array. This example is create a common task in NumPy, and NumPy provides a nice way to tackle it. We can directly substitute the array instead of the iterable variable in our condition, and it will work just as we expect it to. So in here we can write filter array is array higher than 42. This is condition, and cut this, paste here, and paste here, and run, save and run, and we have filter comment this, save and run again, and we have false and false and true. 43 and 44 are higher than 42. And this example we can write comment these, and we can write filter array is array 2 is 0, and copy and paste, and new array is array and filter array. Save and run, and we have false, true, 42 and 44 are even.